কিনা?
জি স্যার, দেখতে পাচ্ছি।
জি স্যার।
গতদিন কয়েকটা পয়েন্ট আলোচনা করা হয়েছে। কিছু বেসিক ইনফরমেশন গুলো আমি একটু রিকল করি। আমার শেয়ারটা দেখতে পাচ্ছেন তাই না? একটু রিকল করি যে আমরা সিনক্রোনাইজেশন এবং মিউচুয়াল এক্সক্লুশন মানে আমরা এখন মেইনলি সিনক্রোনাইজেশন টুল আমরা এই চ্যাপ্টারে আছি তাই না? যেমন আমরা আছে হচ্ছে সিনক্রোনাইজেশন টুল একটু দেখাই। ওপেন আছে কিনা? আচ্ছা আমাদের ওপেন আছে এটা। সিনক্রোনাইজেশন টুল না এখানে আমাদের ডিসকাশন সো today we have detailed discussion on synchronization tool. Okay, so these synchronization tools and their log they are related, they have relation. These two chapters have relation, we can see here. So synchronization tools, we have seen, we have the discussion points, background, critical section problem, Peterson solution, hardware support for synchronization, mutex log, semaphores, monitors, liveness, and evaluation. Okay, these are the discussion topics outlines. So before starting this discussion, I would like to look at my note which I given to the students, or usually I discuss before starting the slides. Slides is a very simple way. So slides are very simply discussed here. So better to understand first the keywords. After that, we will go to the details. Okay. So most of the sections here I will discuss based on the books given here. I already shared the book, right?
জি স্যার।
Okay. Yes, sir. So here you can see this is synchronization and mutual exclusion. Actually, this note I did based on the Stalling books written by Stalling. But the slide is made based on the, you can see here, based on the Silverchair's Galvin and Gang book. Okay. So before starting this slide, I would like to discuss about some very important topics. Okay, very important keywords which will help you to understand this slide. So here we can see synchronization and mutual exclusion. These two keywords are very relative each other. Okay, is relative each other, have relation. Mutual exclusion, synchronization and mutual exclusion. Synchronization, last class I discussed about the synchronization. It's look like anything. So synchronization means whatever the processes will execute one by one or by the given sequence. Okay, this is synchronization. Mutual exclusion means this mutually exclusive way. That means this synchronization should do using mutual exclusion. This synchronization, I think I can show you another uh, No, another page. Next one. This one. Very easy to understand. Concurrency, this is one type of problem. That means concurrency, we need concurrency. That means we need share a memory, or we need to share any device by multiple process. This is called concurrency. That means the concurrent processes need to access a memory space or device. Okay, so this is one type of problem we can say. Actually, concurrency is a process. Is concurrency looks like parallelism. Okay, but it's very fast. Like threads can execute concurrently. That means very fast execution. That means concurrency means, we can say straightly, once a resource need to access by multiple process, but all the processes are ready to access that resource, but there is no permission to access all process together. This is the concurrency problem. Understand? Have you understand?
স্যার
For
যদি
example,
আরেকবার একটু বলতেন স্যার তাহলে স্যার
okay,
একটু
okay. For example, English, we will try to ask any question using English. Okay.
ওকে
Yes,
স্যার
sir.
Okay. Okay. Good. We try. Huh? If you don't understand, then you can ask me. I will translate it. Correct.
ওকে
This.
স্যার
Okay, I have one figure. I need to see first. Anyway, I can draw for you. I always say need to understand some basic keywords before going through the discussion. So here you can see, for example, we have, this is the road. Section, for junction here. Four junctions. Okay. This is we call critical sections. Yes, critical section. I can make it red color. Okay. So this is the roads. We can show this road is like that. This is the middle, divider. This is divider. Okay. This is divider. So for example, this is one, we can see here. So this car is coming from this way. This car is going for this way. And this car is going this way. So this car is going this way, for example. I think if we, your left sided, left sided. This one, this one, this one, and this one. So 4 car is going. So in this case, this red color, what the red color is space. This is called critical section, CS. Okay, so critical section. That means if these four cars want to go all together, then the crash will happen, deadlock. Understand? That means these red color plates need to share. Clear?
Yes, sir.
These four car is ready. From the if this one is number one, if this one is number two, this one is number three, and this one is number four. This four car is ready to enter into the critical section. That means they are very hurry. They want to go. Okay, either they want to go this way or they can go straight. Okay, whatever. If all the four cars want to access this red color place, that means this critical section together, this crash may happen. Correct? So in this way, in this case, what happened? There is traffic light. Correct? If the traffic light in front of one car become green, car one can go straight. Correct? Or the left side. Clear? So if
Yes, sir.
so the number three car also can go straight. Clear? But usually they open one side only. Number one car go first. How many ways? Either this way, left side, or straight, or this way, right side, right? Three ways it can goes. The main thing is this category, red color part, car one, car two, car three, car four, they are ready to access, correct? They are ready to access. In our operating system also have same same occurrence, okay, same issues. Some spaces, memory space, or some devices need to access by multiple processes. That means multiple processes are ready to access that section, that place, that space or that device, whatever it is. But they're ready. That means, but they cannot access because it has only limited permission. Like here, only one can go, one can access the CS part. Once the red light, then two will access this one. Then once the red light on in front of the car two, then three will open. So this is one by one opening access of this red color space, this critical section. It is called mutual exclusion. Understand? This is called synchronization. This synchronization, that means this method is called to synchronize these four cars to overcome the concurrent access of the critical section. Understand?
Yes, sir.
So mutual exclusion means just now I have shown that the mutual exclusion. I will come in this page also. This is the mechanism. So to solve this problem, concurrency problem, we need synchronization to solve. Okay. In the synchronization, we need mechanism. How can we solve this? We can implement this synchronization using mutual exclusion. Mutual exclusive way. That means one after another. We will come to the mutual exclusion, this detailed discussion. And the next one is semaphore. Okay, semaphore is a tool. Understand? This tool used in mutual exclusion. So this figure must be in your head, in your brain. So how a synchronization can establish, how can overcome the concurrency. Okay, concurrency problem. How can overcome? Using synchronization mechanism. Using synchronization method. Inside the synchronization method, we can use mutual exclusion. There is others message passing, monitoring, mutual exclusion. There are different types of mechanism. So we can use either one. So the famous part is mutual exclusion. The famous mechanism is mutual exclusion. Clear? So in mutual exclusion, we can use semaphore. I will come to the semaphore details, inshallah. Okay, now I go to the first page. So it's clear that what is synchronization, what is mutual exclusion, right? Okay, concurrency just now we clear. Concurrent process. Okay, concurrent process just now I have seen that. We have seen that. We say that this 1, 2, 3, 4, this 4 car is ready to access critical section. That means if this 4 is, we can call it process 1, process 2, process 3, process 4. They 4 are ready to access critical section, the red color one. We can call these 4 processes are concurrent process. Okay, concurrent statement. I will show you after that the concurrent statement. Then precedence graph for concurrent process statement. I will show you. The race condition. Yesterday I told you the race condition means based on the our human understanding. So if we go first, reach in a destination, then we can call this is he is the winner. And if anyone go to the behind of the first person, we call the loser. Okay, that means second person, right? In the opposite race condition in operating system is opposite. If any program, if any process, or if any statement in a process execute first, that means it is loser. If any process execute next, that means last, it is winner. Just remember like this way. Semaphore, we have two types of semaphore. Last time I discussed. One is counting semaphore, which is 0 to minus infinity to plus infinity, and the other one is binary semaphore, 0 and 1. But binary semaphore is faster and usually used in operating system. But in some cases, the operating system use general or counting semaphore. We can easily identify where should we use either counting semaphore or binary semaphore. If we see the problem, we can easily say which one we want to use. We need to use. We can see the problem. Based on that, we can identify which semaphore need to use. We can give one semaphore in exam. You can see there is in final exam. You can see there scenario is given. You need to pick yourself which semaphore you need to use for mutual exclusion. Mutual exclusion to solve a concurrency problem. Understand? So if you know the basic, then it will be easy for you to solve the problem. Critical section, just now I told you the critical section, critical resource is either this one can be RAM or any device. Sometimes you can use you use the pen drive, but you want to eject that pen drive or devices. So it shows that that device is busy. That means someone is using other processes are using your pen drive or shared devices. Because of that, it's showing that cannot be eject because another program is running there. Okay.
So can you explain the semaphore again, please?
Semaphore, I'll go detail.
Oh,
Okay,
okay, sir.
two types of semaphore. Just keep in mind that semaphore, two types of semaphore. One is general counting, another one is binary.
Sir,
Okay.
critical resources, explain, sir. Sorry.
Okay, critical
Say again,
resource.
please.
We are going one by one. Critical section. Again, I just show you. That means a shared resource. Okay, if any shared resource, multiple process want to access the shared resource. Okay, if they access all together, then it becomes critical section. You can if you have any land, sometimes you can see some cases in the court, goes to the court because I am saying that this land is mine, but another person want to enter. He also want to, another person say, claiming that this is my land, this is my land, this is my land, this is my land, this is my land. Okay, it means that this is a critical section, that everyone want to get access of that land. Understand? So this place we can say this is a critical section.
And
Clear?
sir, the synchronization means stopping one from entering and let someone else enter one by one.
Synchronization can be like that. If this place is not one by one, it depends. You can give entry to two car together. That means two process can access the critical section together. Okay, it depends on your program, how you want to set the critical section access synchronization. How you set the synchronization. For example, if in your classroom the door is very narrow, only one person can enter. That means synchronization is one by one. Understand? Okay,
Yes,
if
sir.
three
Sir, one
person can
after one,
enter,
sir.
one after one. See, okay, this is synchronization. Depends on the problem. If your room gate is big, that means two-person can enter. Then you can make two line. So two-person can enter into the room. Two by two, two after two. Understand? This is called
Yes.
synchronization. Okay. There is critical resources. We can understand mutual exclusion just now discussed. Synchronization already discussed. Message passing monitor we will discuss later. Huh? It's coming in the discussion. Message passing means message passing. I just give a little bit idea. IPC. It means that indicate inter-process communication. Understand? IPC means inter-process communication. Sometimes we show like that, inter-process communication. This is, we can use this message passing, you can say. Message passing. Oh, it's E. Okay, message passing. So message passing we can do like that. Okay. A. Okay. So message for message passing we can use inter-process communication. That means communicate between the processes and do the synchronization. For example, here, for example, we don't have any light, traffic light here. Sometimes the traffic light is broken. Clear? So the
Yes, sir.
traffic police always wait here in the middle. It shows to the car one like hand, sending message using the hand. Okay, you come. Then number one in this column, whatever the car is waiting there, all cross, all use this critical section. Okay, but once the traffic police show the hand, then they stop. And if asked number two car to cross this critical section, then it comes. Understand? So
Yes,
this is
sir.
the message. This is the
Yes, sir.
message passing. So if the semaphore we don't use the mutual exclusion, we use message passing. That means show hand and count. So something like that. So process, we can send some signal to a process that you can now access to the critical section. For example, four processes want to use any critical section to, but the operating system send message to one process one. You can now access to the critical section. Process one access once it complete its execution and release the critical section, then operating system instructs get send signal to the process 2. Process 2 can access the critical section like that way using message passing. Clear? Okay. Now we
Sir,
go to
I
the
have one question, which is
yes,
when
please.
do we use the message passing instead of semaphore or instead of mutual exclusion?
Instead of mutual exclusion. The mechanism, just now I said the mechanism for synchronization is there are many mechanisms. Either can mutual exclusion, or can message passing, or can monitor. Okay, and there are some more. You can see other books,
Sir,
different books.
even if we use the message passing, do we need the semaphore?
No, message passing is different way.
Okay, sir.
Semaphore is only used in mutual exclusion. Huh? Clear?
Okay, sir. Okay, yes.
The parameter is different. Mutual exclusion they use semaphore. The message passing they use message. Monitor. Monitor they monitor all the processes and give signal to the processes. Randomize. Okay, details we will discuss later. Okay. Next is concurrency. Just now we get discussion about the concurrency. I'll send you. I'll share this file. Yesterday I did not take my laptop, so sorry for that. Uh, because of that, I did not share these files with you. Okay. Next part is about concurrent process. Just now I discussed the processes are concurrent if they exist at the same time. If they exist at the same time. Here, 1, 2, 3, 4, they exist at the same time. They come to at the same time and want to access this red color place, critical section. Okay. The concurrent process can be two types. One is independent process, and the other one is cooperative process. Okay. So independent process is called, that means a process that does not affect or be affected by another process. Okay. Some process they execute, they have all the resources, sufficient resources. They can just execute and they complete their execution. That means there is no what called the sharing
Dependency.
data. No dependency, correct? No dependency. Or another way we can uh, give another definition: any process that does not share any data with any other processes. Okay, so this type of process we call independent process. It does not share or it does not get any. It does not share or no need to share any data. Okay, that means don't take from others, also don't give to others. Something this is called independent process. Okay, the problem in operating system, sometimes your operating system becomes slow because of these cooperative processes. Because of the cooperative processes, all the operating system headache on these processes. So which one is our cooperative process? A process that can affect or get affected by other processes executing in the same system. Or we can say any process sharing data with other processes. In this type of processes, we call cooperative processes. So we need to understand the parallelism and multiprocessor. Parallelism, we know that the two types of parallelism. Coming to our axis, one is single chip, like core 1, core 2, right? Core 1, core 2, core 3, core 4. Like my PC is core 4 PC. My laptop is core 4. That means in one chip, the processors executions are divided into four parts in one chip. If two processor, then we say dual core processor. Another parallelism, that means the process, if I have a process, two process, one process execute in CPU 1, another process will execute in CPU 2. So in this case, we can say single chip, and we can single chip but multiple processes. We call this is parallelism using two processes. Okay, another one is multiprocessors. For example, you have distributed computer in your lab. So in the lab, there are, I think, 30 or 40 computer there, desktop computer. We can execute our program. We can execute our processes or tasks using the multiple processors. That means send task to the multiple computers, and once they're done, they will back to the master computer. Master computer will combine all the results and execute. This is another type of parallelism. That means multiple cooperating processes are running simultaneously on different processor. That means multiple processes actually running in different processor. That means, for example, process 1, process 2, process 3, process 4. 4 processes executing in the 4 CPU by the 4 CPU. That means these 4 processes are executing parallelly. But the concurrency happen. You have to remember, you have to write down the concurrency happen when. That means multi-programming is needed when, for example, two tasks. How the concurrency? Two tasks is ready, P1 and P2. These two processes are ready for two jobs. One is that processes must execute using CPU. Also, that processes use IO operation. Okay, input output operation. How they will do the CPU. First one is CPU cannot execute P1, P2 together because this is implemented on uniprocessor system. So CPU is uniprocessor. That means one processor. That means at least one process can execute through this processor. So P1 execute, for example, P1 execute first. During the time, P2 is not executing, so it can do the I operation if possible. Once CPU P1 complete its execution, then it needs I operation. Okay. Then P1 take the I operation, then P2. Here is showing that P1 and P2, first stage CPU executing P2, then it release P2, then P1 it also release. Now initially here you can see CPU executing P1. So, and P2 is just sitting. So during the waiting time, P2 executing completing its I operation. Okay. So once CPU done, then it also completing the I operation.
Pair, sir.
So like this
Okay.
pair wise. This one P1, P2 first, P1 first, then P2, here P2, then P1. Okay. So like this way, they share the resources one by one and execute. This is using single processor.
Sir, what is PE1 and PE2 in the single chip?
Okay. This is processor element.
Okay, sir.
I think I did not tell you PE1, PE2. I think computer architecture course, you have seen this one, dual core processor, quad core processor, octa core processor, hexa processor. Okay. If
Yes,
that
sir.
one is in a single chip core, then it will show you processor element 1, processor element 2. Okay.
Okay, sir.
Okay, I have shown you there was the synchronization details. This one is concatenate statement. This one I think other teachers they will not teach their students about this. But for the basic clearance for the basic, I think I should explain you how the concatenate statements work. That is, how can we distribute our process serially and concurrently? Concurrent means multiple processes or statements are ready to execute in the same time. So you can see this is the one example statement, concurrent statement. Have you seen? Is it clear?
Yes,
Yes,
sir. It's
sir.
clear.
So these concurrent statements, from this concurrent statement, we need to draw concurrent precedence. We need to draw the precedence graph. If precedence graph is given, you need to write the concurrent statement. It's quite difficult, but if you understand the coding well, programming well, then it's very easy for you. Okay. In this case, we can see begin statement 0, then this begins and at here and end at here. Can you see my cursor?
Yes, sir.
Yes,
Sir,
sir.
here these three things will be same time, in same time.
Three statements are in same time need to execute. Then begin S0, begin and this end is loop. That means this is the range of this begin and end. Okay, this co-begin range is this part. Co-begin and co-end. Okay. So you have to remember that if any statement is given, begin and end, it means it will be serially executed. And if co-begin, that means they need to execute parallelly. Clear? Begin,
Yes, sir.
begin and end. How many statements we have?
3 statements.
Three statements. S0, then a co-begin, co-end. One. This
Sir,
is
S1,
two.
S2, S3 is one statement.
Yes, but I'm talking about the begin and end. In this part, I have mainly three statements. One is S0, another one is co-begin, co-end inside, another one is S4. I said that begin and end, whatever inside the begin and end must be execute, but must be executed serially. That means one after another. Clear? That means from the S0, we need to execute this co-begin, co-end part. Then we need to go to the S4. Then we need to go to the end. Understand? So this is the serially. Okay, that means that S0. So from S0, we can see that S1, then S2, S3, then S4. So you can see three statements, right? S0, S1 to 3, and 4. These three what called the statements are executing here. Okay. So in this case, I will just remember that co-begin, co-end is used for parallel or independent execution. Okay, and begin and end usually indicates serial execution. Clear? Serial execution. Okay, we have another statement. I supposed to make it smaller. How are we are building our precedence graph? We will see. For example, this from the beginning and end, the end statements, chunk of statements are given. Okay, chunk of statements are given here.
Sir, I have a question, sir.
Yes, please.
So why there is divided by into many statements?
This can be your program. Statement means, for example, this is x equal to x plus 1. Okay, S1 can be printf. S2 can be z equal to m plus n, or any other small task. We can say these statements. Okay. So here we can see how we can draw this precedence graph. First of all, we have begin and end. Inside the begin and end, we have S0 and S7. That means S0 and this co-end word, and then S7 need to execute serially. That means S0, then S7. S7 is the last. Okay. S0, then we have parallelly is other statements, and serially another one is S7. Next, we come to the co-begin to co-end. Okay, next we can come co-begin to co-end. We have S1, S2, then S3, S4. That means this one is also under what called. That means we can see S1, then co-begin, co-end. What is co-end? Co-end is finish here. That means 6. S1, S2, and S6. You can see S1, S2, and S6. These three are in parallel. Okay, these three are in parallel. Again, we can see co-begin S3 and S4. Okay, see S2 and this part and S5. S2 is co-begin point this part, and S5. They are in serial. Then we can see S2, then co-begin S3, S4, S4. See, they are in parallel. Then S5 is here because must be serial. S2, then S3, then S5. Okay. After that, we can see that You can see the S6. What is the S6? S6 is parallel. Anyway, after that, we can see the S7. We can find S0 above and the middle one and S7. You can get the formation of all the statements from here. Can you understand? Maybe you can practice little bit 2 or 3 times. If you write, you can understand clearly. We have
Sir,
one more example.
so
That means to
the concurrent statement will be given in the question.
huh?
Sir, the concurrent statement will be given in the question.
Yeah, concurrent question will be given in the questions, and you need to draw the graph.
Okay.
Okay. So you have to try this graph also. You will try yourself, huh? This one. If you don't understand, you can let me know later. Okay, first of all, we need to serially make serial S1, S4, S7, S10 serially. All are in serially. Then we need to have parallelly S2, S4, S3, they are parallelly. S5, S6 parallelly. S7, no. S8, S9 parallelly. Okay, S8 and S9 parallelly executed. So this is the way how can we know the precedence graph and precedence statements. Okay. Next, I think next we can go for okay. Just now I discussed about I discussed about the precedence graph and concurrent statements. Now we go through the semaphore. I would like to go through to discuss about semaphore. So semaphore is an integer variable which is used in mutual exclusion. Okay,
Yes, sir.
is used in mutual exclusion.
Exclusion.
The second one is it is used in various concurrent cooperative processes in order to exchange, in order to achieve synchronization. That means synchronization. To get the synchronization, this semaphore is used. It is a tool, and same thing. That means this semaphore, through this semaphore, a process is controlled to can get access into the critical section or not. Okay, this is the explanation. Two types of semaphore. One is counting semaphore, minus infinitive to plus infinitive. That means -1, -2, -3, -4, then 0. Okay, then 0, then go to the 1, 2, 3, 4 until 1100, like this way. Positive, that is negative, and what is positive? Two ways counting semaphore. And the minus semaphore only 0 and 1. Critical section in graphically, that means in pictorial view, how the critical section looks like this during the programming. So do while is true, that means until true need to do. Okay, until true need to do. So this is critical section. Okay, critical section. So we have a little bit very small functions. How a semaphore, how a critical section is accessed by the semaphore value. How a critical section can be accessed by a semaphore value. Just though I have seen that there are three sections. One is entry section. One is entry section. Other one is exit section. Okay. What the entry critical section, we don't discuss too much about the critical section. We want to discuss, we focus on entry section and exit section. Okay. In entry section, we can see the function name can be down or p or wait. Okay. This is the entry section, the function name. And for exit section, that means if a process would like to access critical section, it must go through the entry section. Once entry section is done, need to once the entry section that to access the critical section is done, then it goes to the exit section and exit and send reminder to the other processes. I already completed my execution into critical section. It has free space. Then you can access. Okay, so like this way, the critical section to access synchronization is established like this way. This is one small program. There is entry section program and there is exit section program. Okay, there is entry section program. Another one is exit section program. Yeah, the entry section counting semaphore for counting semaphore. This is the example. Down means entry section and exit section is up. The name is given because of the value of semaphore going down. If any process enter into a critical section, want to enter into the critical section, the value of semaphore is decreasing. Sometimes it called decreased, sometimes it called down. Okay, sometimes it called, we can see here P. That means the value of semaphore is decreasing here. Okay, so once a process completely execute, it goes to the exit curve. Okay, for the execute, once a process executes, it that means exit. Sorry, after execution, once a process exit from the critical section, it increase the value of semaphore value. Okay. Okay. One thing is how this entry code protect a process. Protect a process. For example, a critical section, it has only one process can enter. What happens if second process come to get entry to the critical section? Needs to apply. That means need to apply. That means need to get entry into the blocked queue. That means once the process get entry into the critical section, it decrease the value of semaphore. If the critical section is occupied, that means the value of semaphore is less than 0, then the process need to put it into the blocked queue. Where? Into the blocked queue. Okay. Once the critical section is released, okay, then it take entry into it. That means once any process, that means the critical section is occupied. Then what it does, it put it into the blocked queue. So once any process is released, then the process wake up The process, you can see here, the process is wake up and put it into ready queue. Here is blocked queue, here is ready queue. Have you understand? I want to show you one example. Semaphore value is 3. Semaphore value is 3. Only 3 process can get entry into the critical section. So when the semaphore value is 3, that means the value 3 is coming here. Can you see my slide discussions?
Yes, sir.
The value of 3, the semaphore value is 3, come here, and 3 minus 1 means 2. That means the semaphore value is now 2. Is it less than 0? Semaphore value is 2. 2 is less than 0? No. That means it will not get entry here. Okay. Otherwise, take entry into critical section. That means now P1, that means P1 can get entry into the critical section. So now the value of semaphore is 2. Second one, we can see there are concurrent processes. How many? 5. But the semaphore controlling this axis. That means 3 means semaphore value 3 means 3 process only can able to access this critical section. Clear? Then P2 come. Once P2 come, that means the value of semaphore is 2. P2 can get entry or not, we will see here. 2. Now semaphore value is 2. Semaphore value minus, that means 2 minus 1. That means 1. Is it 1 is less than 0? No. What happened? Else take entry into critical section. That means P2 easily can get entry into the critical section. Okay, now the value of semaphore is 1, right? Now we have 3, 4, 5, another 3 processes we can see. Now is 1. Semaphore 1. S below is 1. 1. That means 1 minus 1 is 0. Is it S dot value? That means semaphore value is less than 0?
No, sir, equals to
No.
0.
Tabane P3 can get entry into the critical section. See, P3 can get into the. Okay. What about another P4 and P5? They also they are called concurrent process, right? So P4 1 to now is 0, right? Now is the value is 0. That
Yes,
means
sir.
if the value of 0, semaphore, if the semaphore value is 0, it means there's no process inside the no entry allow inside the critical section. So once P4 and P5 now waiting. So P4 want to get access. That means now is value is 0, right? That means 0 come here. 0 minus 1 means 0 minus 1 means koto? What is that? Minus
Minus
1. Then the S value is less than 0. Is it true?
Yes, sir, true.
Yes. Put process into blocked queue. See P4 we put the process into blocked queue. Here is the block queue. Queue means first in, first out. Okay. Okay. Now P5 want to enter into the critical section. So now we have minus 1, right? Then minus 1 come to the S. Minus 1 minus 1. It becomes minus 2. This minus 2 is less than 0. That means put process in blocked memory, blocked queue. You can see P5 also move to the blocked queue. Okay. Next, for example, P1 already exit from complete its work to access the critical section. It wants to exit. It wants to exit. That means semaphore as that means our semaphore value is 0. That means no, there were no permission to others, right? So once 0, then it will increase the value is -1, -2. Okay, because to put the processes into the is called block queue, right? So once the process, any process exit from the critical section, it goes to the exit code. That means semaphore value is 0. 0 plus 1 means 1. Is the S value is less than or equal to 0? Yes. Less than or equal to 0. Yes. Then what happened? Select a process from block queue, wake up and put it into ready queue. That means the P4 was in the first, right? Here was P4. P4 will come first and go to the ready queue. If the P2 complete, it's increase the value of semaphore, then P5 out from the blocked queue and P5 wait into the ready queue. So like this way, the processes can access a critical section, okay, easily. See, there is one example, sometimes in the quiz, this example, this mathematical problem can be solved. For example, if we have the semaphore values 10, that means only 10 process can get entry into the critical section. That means semaphore value indicates the amount of process can get entry into the critical section. Then P entry. Last time we have said the P means entry code. Huh? And P entry, that means 7. That means 7 process, supposed to 10 process need to get entry into the critical section, but only 7 processes get entry. Another 3 supposed to entry but have not. Okay, 7 get entry, but
Sir,
3
we have another class, sir.
Okay, just 5 minutes. Huh? So B exit means 3 processes exit after its execution, exit from the critical section. Clear? So what will be the value of semaphore? What will be the value of semaphore? That means the S new, the semaphore new. The value of S is 10. How many entry? How many get entry is P, and how many exit? Entry during entry code, the value of semaphore always decrease. Because of that is minus P. And when any process exit from the semaphore, exit from the critical section, the value of semaphore increase. So plus V, that means 10 minus 7 plus V, it is 6. This is the S new. So for today, this is the discussion. We will go a little bit more deeper on this topic, inshallah.